These are the Lesson 17 activities for college algebra. Use the following discount function and tax function to answer the questions below. So we've talked about this a little bit in the demo. Now we're going to use it. We want to find the purchase price of a television that costs $250 by first calculating the sale price, so we take the discount, and then adding on the tax. So G of $250, that's going to be the sale price. We just take $20 off. So that's going to be $230. Then we're going to apply the the tax. So 230 times 1.0625 is 244.375. Okay, now I want to find the purchase price of a television that costs $250 by first adding tax and then taking a discount. So 250 times 1.0625, that gives me 265.625. Then take your $20 off and you get 245.625. Okay. So does the order we apply the function matter? Yes. And this is the way we usually do it. If something is advertised as having a discount, you take the discount first and then you calculate sales tax. So like we did in this first one, take the discount first, then add the sales tax. This is the way we usually do it. It benefits the customer, right? Because you end up paying less, $244 compared to $245. So you end up paying less. So that's the way we typically do it. Now we want to look at this picture here. We're composing F with G, visually illustrated here. So we have two function machines. You take your input, put it into the function G, right? Because F composed with G, G is going to be first. So you put X into G. The output is G of X. You take the result, G of X, and feed that into the F machine, and your output is F of G of X. So X must be in the domain of G, G of X must be in the domain of F. Okay, looking at an example, I have F of X equals X minus 300, G of X is 0.85X, and X is 1400. I want to use this information to replace X, G of X, and F of G of X with the appropriate values in the diagram. So X is 1400, that's given. G of 1400, so I want to apply the G formula to 1400. So I'm going to do 0.85 times 1400. And I get 1190. Then F of G of 1400, that's F of 1190. Which means I'm just going to take 1190 and subtract 300. So I get 890. And then I'm just going to write this out, go as thinking of G and F as two machines. So my input is the original 1400. I drop that into the G machine, and it transforms it into a number, 1190. Okay. Then I take that 1190 and I feed that into the F machine, and F subtracts 300, so my final result was 890. Okay, number 3, we've got another example. H of X is 1 over X minus 4, K of X is the square root of X, H of K of 9. Okay, so this is going to be H of K of 9 is a number, so I would evaluate that first because I do the innermost parentheses first. So I take the 9, plug it into the K formula. So that would be the square root of 9, which is 3. Okay, and then I take the 3 and plug it into the H formula, and I get 1 over 3 minus 4, which is 1, I'll write it out, 1 over 3 minus 4, 1 over negative 1, which is negative 1. And then a general expression for H of K of X would be H of K of X equals, and then instead of writing K of X here, I'm going to replace K of X with its formula, square root X. H of square root X. And then function notation says that whatever you replace the X right here in parentheses with, in this case a square root X, you have to replace every x in the formula for h with that thing. So instead of 1 over x minus 4, it's going to be 1 over square root of x minus 4. And then I want to figure out the domain of h of k of x. So the first step is find the domain of the inside function. So k of x, which is square root x. And the domain of square root x is 0 to infinity. So I shade 0 to the right. There's my domain of square root x. Then find the domain of the outside function, which is 1 over x minus 4. So that is all real numbers except for 4. I can't put a 4 in there. So I put an open circle on the 4, shade everything else. Okay, and then the third step is set the inside function equal to the excluded values from the second step. So my inside function was square root x. Set that equal to the excluded values here, which is 4, and solve for x. So square both sides, and I get x is 16. Okay. So 16 is going to be a value excluded from my domain. So my domain is already this, but I also have to exclude the 16. So it's going to be 0 to 16, unioned with 16 to infinity. I like to draw two function machines to make sure that this makes sense. Okay, so here's my k machine. The inside function is k. Okay, so you drop x's into the k machine, and out comes the square root of x. So let's see, if I tried to put in a 0, let's make sure that this is okay. Okay, so I'm going to do the k machine followed by the h machine. If I put a 0 in, k is the square root of x, so the square root of 0 is 0. If I take that 0 and feed it into h, I get 1 over 0 minus 4, which is negative 1/4. Fine, I can put 0. I can feed 0 into k and take the result, feed it through h. Neither machine will jam. Okay. But what happens if I try to put in, say, a negative number? Okay, so if I try to put in like negative 4 into the k machine, k is the square root machine, and the square root of negative 4 is not a real number. Okay, so negative 4 will jam the k machine, so I can't plug it in. So I can't put negatives into the k machine, so they are immediately eliminated. Okay, they will jam the first machine. Now, we figured out here at this step that you can't put an x into the k machine because it will jam h. So let's see what happens if I try to put a 16 into the k machine. So the k machine will square root it, and I'll get a 4. And then the h machine is 1 over x minus 4, so 1 over 4 minus 4, which is 1 over 0. We jammed the k machine, the h machine. So 16 can go into k just fine, but the result, when you try to plug it into h, will jam the h machine. That's what this third step is doing. It's saying, make sure that k will never produce something that will jam h. And so 16 is the thing you can't put into k because it would produce something that will jam the h machine. Number 4, evaluating composite functions using graphs. All about inputs and outputs. So let's just get into it. So f of g of 4 means take your 4, plug it into g, right? So g is the red graph. So I'm going to find an x value of 4 and read the y value off the graph of g. Okay, so here's my x value of 4. My g is the red graph, so I go down to g, and I read off the x value as negative 2. So I'm going to replace the g of 4 with a negative 2. And then f of negative 2, now I'm going to find negative 2 on the x-axis, read the y value off of the graph of f. So here's x is negative 2. I go up to the graph of f, read the y value, I get 2. Okay, so let's repeat for g of f of negative 3. So I start with f of negative 3. So negative 3 is my x value. The first function is f. The innermost function is f. So I'm going to go up to the graph of f, which is the blue graph. Read the y value, and I have 5. So this is g of 5. And then I find 5 on the x-axis, and I read the y value off the graph of g this time, which is negative 3. Now f of negative 1. So I start with f of negative 1. So I go negative 1 on the x-axis. I go up to the graph of f and read off the y value. So f of negative 1 is 1. And then f of 1, so I find 1 on my x-axis. I go up to f again, using f twice, and read off the y value, and I get 5. G of 4. So start with the 4, that's my first x value, plug it into g. So I'm going to get the point on g that has an x coordinate of 4. So I find 4 on the x-axis. I go down to the graph of g, read the y value is negative 2. So replace g of 4 with a negative 2. And then g of negative 2, so now I'm going to find negative 2 on the x-axis and read the y value off the graph of g, which is the red graph, and that is 4. F of g of f of 1. So we start innermost parentheses first. So that 1 is my first x value, and I'm going to plug it into f. So f of 1 is the first thing I need to evaluate. So I have the x value of 1. I'm going to go up to the graph of f, the blue graph, read off the y value. I get 5. So I'm going to replace this f of 1 with a 5. So this is f of g of 5. Okay, so the next thing, if I'm working my way inside out, is to find g of 5. So x value of 5, plug it into g. So here's my x value of 5. G is the red graph, so I go down to g, go over, read the y value, and I get negative 3. So this is g of 5. Replace that with a negative 3. So this is f of negative 3. So now I find negative 3 on my x-axis, and I'm going to get the y value on f. So I'm going to go up to the f graph, read off the y value. And it is 5. Okay, I'm going to skip this last one and just leave it to the reader to make one up on your own. Number 5, I have two functions, f and t. The first function, f, gives the number of gallons of fuel, f for fuel, a jetliner uses as a function of time in hours, t. And the second function, t, gives the time in hours as a function of the number of miles flown. So we want to estimate t of 500 using the graph. So that's going to be my second picture. This is my t function. So I wrote t of d here. It might be helpful to just put a big T there. This one is f. So t of 500. I'm going to find 500 on here. Looks like right there. Go up to the graph. Read off the y value. Looks like about 1. T of 500 looks like it's approximately 1. Give the meaning in words, including units. So to fly 500 miles. Okay, and then the output is time in hours, so takes approximately 1 hour. And then I want to estimate f of 1 looking at the graph. So here's 1. Go up to the graph of f. Read off the y value. Looks like about 250. So f of 1 looks like approximately 250. And again, give the meaning in words. So my input here was time in hours, so 1 hour. And the output is fuel used in gallons. So 1 hour of flying uses about 250 gallons of fuel. All right, and then find f of t of 500. So to calculate this, do the innermost parentheses first. So f of t of 500, we know what that is. We estimated it earlier. It was 1. And f of 1 is 250. So I'm going to write this all out. So f of t of 500, that's f of 1, which is 250. So now my input is 500, my output is 250. So this says to fly 500 miles uses 250 gallons of fuel. Okay, so now I'm going to give you equations for the graphs. So instead of just estimating by looking at the graph, we have formulas. So f of t is 250 times the square root of t, and the t of d formula is d over 500. We're just going to repeat these questions again, but we're going to use formulas instead of the graphs to get the answers. So t of 500 would be 500 over 500, right? So I'm just replacing this d in the formula with a 500, and that is 1. Okay, so same result we got up here looking graphically, we get that same result here algebraically. And then to find f of 1, okay, so that would be 250 times the square root of 1, which is 250. Okay, so I just plugged into the f formula. I replaced this t with a 1, so I replaced the t in the formula with a 1, and I got 250. Same result that I got up here visually. So then f of t of 500, t of 500 we know is 1, f of 1 we know is 250. So same result because it's the same question, just using the formulas instead of the graphs. All right, so now I want to find f of t of d symbolically without plugging in numbers. I just want to have a formula for f of t of d. So f of t of d. So I can't put in a number for d. I don't have a number. So instead, I'm going to replace t of d with its formula, which is d over 500. So this is going to be f of d over 500. And then I use what I know about function notation that says, look at the formula for f. Whatever you replace this t with that's in parentheses, you have to replace every t in its formula with. So I replaced this t with a d over 500. I'm going to replace every t in the formula, which is just this one, with a d over 500. So I have 250 times the square root of d over 500.